Hi, here is one of the equations that you need to know for physics. It's one of many. Mostly nowadays they put them on the paper, not the equations, but you need to know the units and understand what it's for. Now this one's pretty good actually, it makes total sense. So what I want you to do is choose a couple of things on your desk or nearby, small things, and preferably not the cat or something like that. And then you need to flick both things, like a pencil and a pencil case, across the desk or table. Try and use the same force to flick them with. Now you should notice that one goes further than the other. You might not. Yeah, because there's all sorts of reasons why that might not happen. Friction, air resistance, etc. Your rubber stuck to the table, so that wasn't much good. But anyway, really what happens, the more mass it's got, the more force you're going to have to flick it with to give it a good acceleration. What you're seeing there, with the same force, the one with the less mass has a higher acceleration. Let's have a look at these two bags. Here, by looking at them, which of the bags needs more force to pick it up? So how much force are you going to need? Pick up the bag. The big one, that's right, the one with the more mass. So the more mass to accelerate upwards, I'm going to have to use more force. Now, if I pick both of them up with the same force, which one would come up to my waist height quicker? Well, pretty obvious. The small one, the 1 kilogram, the one with the smaller mass. Okay, that's because it takes less force to accelerate it. And with the same force, the smaller mass will accelerate more. So let's look at some of the sort of questions you might get. Well, you won't get it quite in the way I've written it, but there you go. Now I've put the triangle there. Oh, quick, get rid of it. I've put the triangle here for you to try and use it. Now it's one I've made up. It's FAM. That just helps me remember it. It's not something that you could quote in an exam. This is the thing that you need to know here. And we've got force in newtons, remember, mass in kilograms times acceleration in meters per second squared. Here's the first question then. Calculate the force, so that's this, we're looking for the force, needed to accelerate a 50 kilogram mouse through its hole with an acceleration of 20 meters per second squared. Now what I tend to do, or tell kiddies to do, is to highlight the figures. So that is mass. I'm using the mouse here, so bear with me. And that there is acceleration. So what do I do with those two? I times them together. So 50 times 20, 1,000 newtons. Don't forget those newtons because they are worth valuable points. The next one. So I'll use a pen again. What is the mass of an elephant? So you're looking for mass. Who is pushed with a force of 1,000 newtons. That's that, which must be force. Yeah. And this accelerates at a rate of 10 meters per second squared. So A, that must be A. Now with the meters per second squared, you don't have to square anything. It's like centimetre cubed. It doesn't affect the numbers. Don't worry about that. So we've got F and A, so it's 1,000 divided by 10. Now the golden rule is, I don't care if you think you know the answer, I need you to put it in a calculator, just in case. And I'm going to do that because this is where silly mistakes happen. And the answer is 100. 100 what? Mass. Kilograms. Okay, 100 kilograms. So that's the answer. This one down here is higher tier because it combines two different equations. Here you've got a change in velocity, okay, a change in velocity, and you've got the time taken. So that is the equation CAT, the change in velocity equals acceleration times time. That will give you the acceleration, which you can then use to in the equation with the force. So here we've got the change in velocity is 10 divided by the time taken equals 5 meters per second squared. Once I've got the acceleration, I've got the force, so it's force divided by acceleration. So that's 600 divided by acceleration is 5, it's 120 kilograms.